Hello, everyone, and welcome to my class. Today's topic will still be algebra, since it's very important and stuff. Yes. All right. Okay. Can you see my screen? Say yes in the chat. And also, in case you didn't know, Edward, you're chatting to me, not to everyone, so no one can see your messages. Too sad. Okay. All right. Let's start. So our schedule, first we'll start with word problems, and then we're going to learn about complex numbers. And then we are going to learn about unique equations, and these are not your average linear equations. There's a bit harder to solve, not very classic style. So, let's begin. Word problems. Number 1. Emily can deliver newspapers to all the houses in her neighborhood in 45 minutes. If her brother helps, they can deliver all newspapers in 20 minutes. So how long will it take for Emily's brother to deliver all the newspapers himself? Okay, very classic problem here, delivering newspapers. Okay, I'll give you a few minutes to solve this and then I'll go over it. All right. Does anybody know how to solve this? Or do you need more time? All right, I'll give you a bit more time to solve this. This is how you solve this is actually quite simple. All you need to do is you just need to solve it using the same method when you solve that pump A and pump B problem. It's the same concept. Should be pretty easy. All right. So let's begin since no one has the answer. Very sad. All right. So basically, Emily can deliver newspapers in 45 minutes. So let's say so this is the amount that she can deliver in 45 minutes. All right. So basically, it's basically the amount she can deliver over the time. And then we're going to add that since her brother and Emily are working together to deliver these newspapers. So that'll be 1 over x. Since we don't know how long it will take for Emily's brother to deliver newspapers by himself, and that equals 1 over 20, because together, combined, they delivered newspapers in 20 minutes. All right. So what we need to do to get rid of this action is multiply the whole thing by 180x, which is the common denominator of 45, 20, and x. So let's do that. So it'll be 4x plus 180 equals 9x. So 5x equals 180, x equals 36. All right, so it'll take Emily's brother to deliver the newspapers all by himself for 36 minutes. All right, so how do we get 1 over 45? This relates, as I said, in the last lesson. This relates to distance equals rate times time. It's just in a different perspective. Basically, it just fits to the problem. So we need to find the rate, right? So basically, it's distance over time equals rate, and that will be like delivering newspapers to all the houses in 45 minutes. That will basically be the rate. The distance will equal the amount delivered, and the time will be 45. The amount right here doesn't really matter. I just use 1 because it's the most simple way. Even if you substitute this one for a 2, and you substitute them all for a 2, it's still the same result. So that's how you get this equation. And a lot of these word problems are very similar to these, so you need to know how to do this. So does everybody understand how I get this equation? Okay. Say yes if you understand. So nobody understands. Oh, that's just too sad. Too bad. Oh, 2 comments. Yes from Edward. Period from Kai-C, and yes from Steven. All right. Good enough. This is a bit harder, but it's hard to visualize. The equation itself isn't very hard. It's just hard to kind of apply your skills to derive an equation. I mean, it's not like you actually have a quadratic equation in front of you to solve. You just actually need to solve this, derive an equation, which is the hardest part. So, an airplane flying north at 200 miles per hour passed over a point on the ground at 2 p.m. And don't start solving it now. Draw a diagram for you to help you understand better. All right, and another airplane flying at the same altitude passed over the point at 2:30 p.m. All right, flying east at 200 miles per hour. All right, so let's say this building is our point on the ground. All right, and we have this plane who was flying over here. Okay, this plane is flying north. All right, and this plane is flying at 200 miles per hour. And then we also have this plane. All right, this plane is flying east at 400 miles per hour. All right, so this is basically the diagram. So you see this right angle here, you should basically get the idea already. Pythagorean theorem. All right, so if you want to find the distance between them, then you need to derive an equation and then get the Pythagorean theorem. All right, so that's how you're going to get it. And since this is kind of, we're working with very big numbers right here, and we're supposed to use the Pythagorean theorem where you're supposed to square these numbers. So I'll give you, you can use your calculator with this one. You can use your calculator. And I'll give you a bit more time to do this. But the equation itself isn't that hard, so yeah. And also, when these problems you need to pay attention to, because there are 2 problems here. There are 2 questions here. One is that at what time, wait. Oh wait, I didn't include the second question. All right, whatever. Ignore what I just said. But in some future questions, there will be two questions or two problems for you to solve. So make sure you answer both question A and question B. Basically like a two-part question. Oh, yes, of course. Your weakness, Stephen. Your weakness. Oh, that's sad. Oh, that's my weakness as well. I hate speed and distance and time problems. Well, that's exactly why I'm giving them to you, because they're hard. Oh, Jenny, you don't understand. Oh, that's sad. Well, I'll just go over it once the time is over, so hopefully you'll understand after I'm done explaining it. All right. So nobody understands. Oh, that's even more sad. All right. So this airplane flying 200 miles per hour north. All right. So at what time after 2:30 p.m.? Pay attention to that. Pay attention to that. All right. So what is our Pythagorean theorem again? It is a squared plus b squared equals c squared. All right. So basically, we're going to have how the distance that this north plane is traveling and the distance that this plane traveling east has already traveled, and basically use the Pythagorean theorem. Right. So since we're calculating time after 2:30 p.m., we actually need to basically have we're going to need to derive a formula that basically calculates the distance after 2:30 p.m., not at 2 p.m. And since this airplane flying north passed over this point at 2 p.m., then that means that this airplane has flown, has what's the correct word for it? Has flown, has flown, has flew. Oh, is it flown? Is it flew? Oh, basically, it's basically because this airplane has traveled 30 minutes longer than this east airplane because it hit the point at 2 p.m. So we're going to have to include that. So the time after 2:30 p.m. can be denoted as t. All right, and since we can just do that, so the east airplane is just going to be 400 times t because it's 400 miles per hour. So basically 400 times t. That's the time after 2:30 p.m. However, it's a different case for this north airplane. We're just going to call them N and E. All right. Hopefully you understand. And so basically, since this airplane has traveled 30 minutes more than this east airplane, it's going to be t plus 1/2. Since we're using hours here, 1/2 means 30 minutes, 200. All right, so after we're done with that, okay, we need to actually put this in the the Pythagorean theorem. So d, which is the distance, should be, and actually the distance here is going to be 500. So let's put that in there. So all right, 500 equals, never mind. We need to actually derive the equation first. So hold on a second. Okay, so let's just use d and t right now. So d equals the square root of this squared plus this squared, because that's basically a and b squared. So are there any questions so far before I want to derive this equation? Are there any questions? Do you understand? If there are any questions, I would like to go over them now before I start going over this equation. Any questions? No questions? If you do have any questions, it's your time, you know. All right. Then no questions. Let me continue. So, basically what we will do is this squared. What is that squared? All right, that is basically 200t plus 100 squared plus 400t squared, which is just that's okay. Now we have our equation. Now let's simplify, and then we can just plug 500 in for the d, because we need to find at one time after 2:30 p.m. were the airplanes 500 miles apart. So those are the key points. Now, Stephen and Edward, you guys are pretty good. Can you do this now? Very easy now. All you need to do is simplify, and you need to solve the problem. Can you do that, Stephen? I'm not going to do all your work for you. Do you need any help with this now? I've already given you the equation. Stephen, are you dead? Oh, no, you're not. No help. All right. Okay, I'll wait for you. Edward, how about you? Can you do this? Edward, are you also dead? Yes, you're also dead. All right. So, aside from the dead people, are there any questions here? Any questions? All right. And because of Stephen's Godspeed, I suppose he's already solved it. I'll just give you some time. Okay. Never mind about that Godspeed. All right. So this is the equation. Anyone else's? Feel free to do this. It's a very easy equation, you know. Very easy. I've already given you the equation. Now you just need to solve it, right? It's very easy to just like square this, right? Square it. Oh, and common mistake here, kids. Actually, I'm a kid too, so that didn't make sense. All right, common mistake here is that don't square 200t and 100, all right? This right here is 200t plus 100 times another 200t plus 100. So if you're trying to solve this, don't make that mistake, and yeah, your answer will be very, it will be smaller than what it's supposed to be, so. All right. Okay, so I'll wait for everyone's answer if you do know how to do it. If you don't, then I'll walk you through it later. All right. All right. Apparently Edward has an answer. Hopefully it's an answer. Oh, all right. Huh. Oh, Edward. So sad. So sad. Is that your final answer? 4 o'clock p.m. Okay, that is incorrect. Very close, though. That's very, very close. Steven, do you have an answer? Anyone else? All right, Steven, you're being too slow. Even Edward has surpassed you. I guess your weakness is time and distance problems, so I don't blame you. Oh, you're kind of stumped, aren't you? Come on, it's simple calculation, kids. So what you do is you're going to expand this and this. I mean, it's just simplify it. All right, just simplify, and then substitute 500 in. All right, so let's do this. It's basically 200t squared, 40,000, I think. 40,000 t squared, yep. And then that's about another 40,000. Wait a second. Oh, never mind. Oh, wait. Oh, I see. Okay, so that will be 40,000 t because basically it's 2xy. And then, okay, this 0 looks trash. So let me fix that. Okay, plus, what's that? 10,000, yep. 100 squared. And then you forgot about this, okay? Forgot about it. And then you need to still add something more. What's that? 60, okay. That's what it's supposed to be. All right, very big numbers here. So now you just need to simplify, all right. Okay, so after, I'm just going to save you the trouble and tell you the answer here. It's going to be 100 times 20t squared plus 4t plus 1. All right, so basically after you add these two together, all right, and actually this 160,000, that's a t squared. All right, so you can combine like terms. You get 200,000 t squared, and then you take off what? This is 10,000. All right, and square root that, and put it outside the square root. So now you have a simplified equation. So now what we're going to do is, I need more space, so I'm just gonna erase this real quick. Hopefully everybody take notes about that before, okay? And then I'm just gonna erase everything first. I just need more space here. Okay, so now that we've gotten our basic equation here, all we need to do is very easy. I'm gonna move the equation here. All right, so basically, since at what time after 2:30 p.m. were the airplanes 500 miles apart, which means we know that the distance was 500. So 500 equals 100 times the square root of 20t squared plus 4t plus 1. All right. So now what do? Divide both sides by 100. Okay, we need to simplify. So 5 equals the square root of 20t squared plus 4t plus 1. All right. Okay. So now what we need to do is we need to because we have a square root here, we need to square both sides. So square both sides. Basically, you get the quadratic equation 20t squared plus 4t minus 24. All right, equals 0. And then you see here, there's a common factor of 4. So you can just simplify. 5t squared plus t minus 6. That is how it's going to be. And then, all right. Oh, okay. So now what you need to do is you need to factor by grouping, okay? Or we can do the quadratic formula. And since factor by grouping is a bit slow, let's do the quadratic formula. So let's do that. All right. So quadratic formula is x equals negative b plus minus square root of b squared plus minus 4ac over 2a. All right, so let's a equals 5, b equals t, b equals 1. That was sad. B is 1. All right, this is sad. B is 1, c equals negative 6. All right, we're ready. So t should equal negative 1 plus minus the square root of 1 plus 120 over 10. All right, let's do this. One solution is going to be equal to 1, of course, because negative 1 plus minus 11, because 121 square root is 11. So 10 over 10 is 1. The other solution, negative 1 minus 11, that's going to be or negative 6 over 5. And we all know that there's no negative term, so cross out this solution. 1 will be the solution. So at what time after 2:30 p.m.? That's 1 hour for you, so 3:30 p.m. That will be our answer. And this M looks very sad. All right, that's good. And I just wasted about 15 minutes on this problem. This is sad. So does everybody understand? Okay, yes, 3:30 p.m. Yeah, you solved it incorrectly. Well, good job for Edward. At least you tried. All right, well, good job to everyone, because I hope everyone understood this problem. Are there any questions about this problem before I move on? I don't think we'll be able to do any word problems. I still have one, but looks like we're not doing that one. We're running out of time. All right. Any questions? If you have any questions, say yes. If you don't have any questions, say no. Okay, no questions. No questions, good. All right, so now we will start at complex numbers. So, can anybody tell me what they know about complex numbers? All right, and what are complex numbers? What are complex numbers? Complex numbers, and we're going to be working with I today. All right. Stephen, very close. No. It is A plus BI, not AI plus B. Yes, when I equals the square root of negative 1. Yep. Okay. So I basically equals the square root of negative 1. And we all know that we can't take the square root of negative 1. So that's why it's an imaginary number. All right, complex numbers, imaginary numbers. I is an imaginary number in a complex number. So basically, when we have the square root of negative 3, okay, we have square root of negative 3. Okay, that equals the square root of negative 1 times the square root of negative 3, which basically equals I times the square root of negative of 3. All right, so I times the square root of 3. So that's how to simplify using I. So let me introduce some theorems. All right, common theorems. First of all integers are complex numbers. Basically, this means complex number is a number that involves an imaginary number like I or other complex numbers. All right, so a complex number involves I. And now you don't think, wait a second, 3 that doesn't involve I. Okay, it doesn't involve I in any way. It's an integer, but no. What is 3? 3 equals 3 plus 0I. So it is a complex number. 2, that equals 2 plus 0I. Same thing. As long as there is I present, then it is a complex number. Maybe it's 0I, but it still counts. So all integers are complex numbers. All right, everybody take notes. Hopefully. Second theorem. All right, second theorem. A plus B. My pen is acting up again. A plus BI equals C plus DI if and only if A equals C and B, hold on, why can't I write? Oh, there we go. B equals D. All right, if and only if A equals C and B equals D. That's, you might think, oh, well, that's common sense, right? Of course, so equal 2 plus 3I equals 2 plus 3I, right? No. What I'm gonna ask you to solve will be something like 3x plus 4y minus x times I equals 2 plus y minus 3x plus 1 times I. All right. So that is basically how we're going to solve this. All right. So we have this very complicated looking equation right here. But using this theorem, we can conclude that, let's say this is A, this is going to be B, this is going to be C, this is going to be D. All right. So, and we know that since that is equal to each other, then A equals C, basically meaning 3x equals 2 plus y. All right. And we can also get that 4y minus x, all right, equals negative 3x minus 1. Basically this and this. So using this theorem, we can just get a systems of equations. So everybody knows how to solve systems of equations, right? Basically, all you need to do is just put this in a way that how you would solve it easily, like 3x minus y equals 2, and then 4y plus 2x equals negative 1. All right, we're done here. We just need to solve the systems, right? And then after we solve, I'm just going to save you the trouble of solving this. All right, x is going to be equal to 1/2 and y is going to be equal to negative 1/2. So that's, don't worry about solving the systems. You already know how to do that. But the main point is this theorem. All right, so whenever you come across a problem like this, then you can use this theorem. So, is everybody taking notes on the theorems? Everybody taking notes? All right. Very important. Okay. So, and I have two more theorems to go over. Now, complex numbers always have natural additions and multiplications. All right, so we're gonna have the use of z and w. So z equals a plus bi, and since z is a complex number, all right, w is also a complex number, c plus di. All right, so complex numbers have natural additions and natural additions and multiplications. All right, so you'll figure out what I mean by that. All right, this natural looks very unnatural. Better. All right. Natural addition and multiplication. So z plus w equals a plus bi. Okay, a plus bi plus c plus di. All right, we never, when we're simplifying these, we never put the I next to D or B, right? So what we're gonna do is A plus C. Okay, that we're gonna add these what constants together plus B plus D, and they're bound by I, this factor. All right, so that is the factor form. Okay, that is a simplified form. That is the natural addition of complex numbers. So that is a pretty useful technique when you're multiplying or adding them. So for multiplying, z times w. Now, then we just need to basically a plus bi times b c plus di. Hold on a second. And we're going to get ac plus ADI plus BCI, and then plus, actually, the funny thing about this is when you square I, it's basically -1, right? So, because it's the square root of -1 squared, it's just -1. So BDI squared, that is basically minus BD, right? That's basically minus BD. So it's just minus BD here. So the natural multiplication would equal to AC minus BD plus AD plus BCI. All right, so those are the natural addition and multiplication. And whenever you have something like this coming up, you can just use the simplified form of that, because it's kind of hard when you have complex numbers and you're trying to multiply it all out. So, all right. Any questions so far? I'll wait for questions. If you don't have any questions, say no. If you have any questions, say yes. And then proceed to ask a question, because we don't have all the time in the world. Any questions? No. All right. Okay, then I will keep going. So conjugate theorems. All right, so what is a conjugate? So let's say we have this negative 2 plus 7i over 3 plus 4i. All right, so when we're simplifying, we can't have a complex number in the denominator. All right, so what we're going to do is that we need to multiply by the conjugate, which is just reverse this sign. All right, when you're adding something, just reverse the sign. All right, so basically it's just multiplying by 3 minus 4i over 3 minus 4i. All right, so after we do this, you see the bottom here, we're squaring I right here. All right, we are squaring I. Okay, and we get negative 1 out of that. And when we multiply 3 x plus y times x minus y, it's basically x squared minus y squared, right? So in this case, I is squared, which reverses this sign. So basically it's 9 plus 16, which results in 25. All right, and then we just need the top part, which after you can multiply it, we're going to simplify to 22 plus 29i. Right? So, but we're still not done yet. So we need to do 22 over 25, separate them, plus 29 over 25i. So now we're done. All right. So does everybody understand the conjugate? Everybody understand the conjugate? Are there any questions on the conjugate? No questions? All right, so now for some conjugate theorems. So let's erase this real quick. Okay, so first one is that the conjugate of z plus minus w, and this bar here means conjugate. Okay, this bar means conjugate. So a bar means conjugate. Well, when you're working with complex numbers, but let's say you have 5.6 bar. Okay, that's just repeating sign, but when you're working with these variables, then that means conjugate. All right. With decimals, it's repeating. With this, it's conjugate. All right, so basically the conjugate of z plus minus w is basically the conjugate of z plus minus the conjugate of w. All right. So, the second one is z times w, the conjugate of that equals, okay, this handwriting is super trash right now. Okay, the conjugate of z times the conjugate of w. So you kind of get the idea. Same with division. Conjugate of z over w equals conjugate of z over the conjugate of w. First one, which is kind of interesting, is that z, the conjugate of just z, if then the conjugate of z equals just z, if and only if z is real. All right, so the conjugate of z equals z. if and only if z is real. So, very interesting. So now let's actually prove some of these. You can prove some of these, all right? How about let's prove the first one, all right? Let's prove the first one. Okay. So basically, the conjugate of z plus minus w equals conjugate of a plus bi plus c plus di. Now, basically, that is going to be equal, since we already did the natural addition, that's going to be a plus c plus b plus d times I. So, that's exactly what we're going to do. Now let's take the conjugate of it, which is just change this to a minus sign, reversing the sign. Actually, there's no conjugate anymore because we just did that. All right, so let's do this. All right, so this is what it's going to be. And then, you see here, it's going to be a minus bi plus c minus di. All right, so basically that results in the conjugate of z, which was a plus bi, and the conjugate of it is a minus bi. So in w's conjugate, c minus di. So basically that's what happened. So that is how we prove this, and ultimately it results in the conjugate of z plus the conjugate of w. Are there any questions? Any questions? No questions? All right. So let's go over some unique equations. Absolute value, boring. Oh, this is nice. No, that's still boring. Oh, I feel like we can do that. No, that's still boring. I'll do that next class. Oh, this looks interesting. All right, let's do this one. Who knows how to solve this one? Who knows how to solve this one? I'll give you a few moments to solve this one. I doubt anyone can solve it though. Well, if it is my job to teach it to you. So, any attempts on solving this? How do we solve this? Any attempts? Who can solve this? Are there any ideas? The heck? Oh my god. 8 and negative 27? How are you so fast? Oh, well, that's correct. All right. Okay, congratulations, Steven. So, what I assume what you did was you substituted x to the 2/3 for something else. Right, so let's use u. U equals x to the 1/3. U squared equals x to the 2/3 power. So basically what you get here is u squared plus u minus 6 equals 0. And then it's going to be, oh, it's going to be, hold on a second. So basically what we did here, we just substituted the x to the 2/3 power for u, since we can't really do anything with that, right? Can't really do anything with that. So we can't multiply it by, we can't raise it to the power of 3 because that would be very troublesome. So basically what we did here was we had we just had to substitute it for u, and it works out perfectly. U and u squared. So after we factor u plus 3, u minus 2 equals 0, okay? And we get u equals -3 and u equals 2. Since u equals x to the 1/3, we need to cube both sides to actually get x. So let's cube these solutions. X equals -27 and 8. Congratulations, Steven, not Steve-Bird. Oh, that sounds stupid. All right. Congratulations, Steven. All right. Okay, good. That's exactly what you did. At least someone understands. All right, that will be the last. Yes, of course I called you C-word. That will be the last problem of today. Thank you, everyone, for coming. All right, so I'll end recording. Okay, hopefully you come to next week's class. Still algebra, still boring, but at least you get smarter.